Since we give this question, a radioactive isotope has an initial mass of 200 milligrams, which 2 years later is 50 milligrams. Find the expression for the amount of isotope remaining at any time t, and also find the half-life. So we would have to have a differential equation. So for that, we would make the following assumption. So we would start by saying, let A be the mass of the isotope, okay, after t years. Now let K be the constant of proportionality. Okay, so this is 0.1, this is 0.2. Therefore, the required differential equation is dA. We are always looking at the isotope with reference to time, so it has to be dA over dt is equal to. Now, if you see the question, the isotope, the radioactive element, will always be disintegrating. That means it will always be reducing. It starts with 200 milligram and it reduces to 50 milligram. So the constant of proportionality should have a negative sign. Have that in mind. And that has to be multiplied with the amount of isotope to start with. So this would be the required differential equation. So this is a very important understanding you need to have. Next, what I'm going to do, I'm going to be separating the variables. So from here, this would mean I can rewrite this as dA divided by A is equal to negative K times. I move this dt to the right, so this is what I get. Now, integrating, we get, you got to get the equation, right? So you need to integrate. So when you integrate, on the left, it's going to be ln A. On the right, it's going to be negative K times integral of dt is going to be t. Now, positive ln, it's going to be a constant, right? It's an arbitrary constant. Now, remember always in application-oriented problem, instead of just placing it as C, since I have a ln on the left, place it as ln C. It's an arbitrary constant. So you can always do it like that. Now, moving this ln C to the left, I would get ln A negative ln C is equal to K times t. Now this is going to be ln of A over C is equal to negative kt. Now you know that ln A is actually as a base e, and if it is equated to b, then I can write A is equal to e raised to the power b. I can do that. Because of this formula, I can rewrite this as A over C is equal to e raised to the power negative k times t. I move the c, and that would mean I get A is equal to C times E raised to the power negative K times T. So this is the equation that I have got. Now we are given the following thing. Okay, the following information has been given. What is it? Now we are given that when time is equal to 0, the amount of isotope is given to be as 200 milligram. This is given. So if I were to take this as equation 1, so therefore I can rewrite equation 1 to be as 200 is equal to C times e raised to the power negative K times 0. This is going to be equal to 1. So this would imply I now have C is equal to 200. I know the value of C. So therefore I can rewrite 1 to be as A equal to 200 times e raised to the power negative K times T. So this is what is the new equation or the new system. Now we are also given that the isotope reduces when time t is equal to 2 years. The reduction becomes to 50 grams, okay, the 50 milligrams. The isotope gets reduced to 50 milligrams. So you need to have a new system to accommodate that. So if I were to take this as 2, therefore 2 can now be rewritten as 50 is equal to 200 e raised to the power negative K times T. Okay, so I can bring 50 divided by 200 is equal to e raised to the power negative K times T. I can always write it like this. And from here, since T is equal to 2, because it's given, right? T is equal to 2, A gets reduced to 50 milligrams. So this is going to be rewritten by reduction, and 5 divides here 4 times. So I can write this as e raised to the power negative 2 times k is equal to 1 over 4. This is what I have got. I need to obtain the value of k. So what I do, I take ln both sides. So taking log both sides, you get ln e raised to the power negative 2 times k is equal to ln 1 over 4. As I mentioned to you, you can use this formula. Now since ln a raised to the power b is going to be b times ln a, using this formula, I'm going to use the space here. I can rewrite this as negative 2 times k is equal to, now I'm not placing the ln e here. Why? Because you got to know ln e is equal to 1. Have that in mind. So that's the reason I'm directly writing it as negative 2k, and that is equal to ln 1 over 4. Now, but I need to get the value of just k. So that can be easily obtained in the following way. I don't want this negative sign here. So what I'm going to do, I'm going to be multiplying by negative 1 both sides. So when I multiply by negative 1, this is going to be positive 2 times k is equal to negative ln of 1 over 4. This is actually a negative 1, right? Now I can use this formula. See, b times ln a can be rewritten as ln a raised to the power b. So this negative is nothing but a negative 1 there. So I can move it to be the exponent value for 1 over 4. When I do that, I get 2 times k is equal to ln of 1 over 4 raised to the power negative 1. I can flip this quantity and rewrite this as ln of 4, which is equal to 2 times k, right? This is from algebra. Ln of 1 over 4 with the exponent being negative. I can flip it and write it as ln 4. I need to get the value of k alone. So therefore, from here, the value of k is going to be equal to 1 over 2. You bring the 2 down. So 1 over 2 times ln 4. So this is the value of k. Now after obtaining the value of k, we can answer the final question, which wants us to obtain the half-life. Now the final question wants us to find the time it takes for the isotope to reduce to 100 milligrams. See, when they are talking about half-life, okay, this is called the half-life. So they want you to find the time it takes for A to reduce from 200 milligram to 100 milligram. So this is what they are looking for. That is what is called as half-life. So the value of A is now going to be 100. I know the value of K. I am expected to find T. So in this case, T is going to be TH. Okay. So I can write that down. Let TH be the time required for the isotope A, okay, to reduce to 100 milligram. Okay, so therefore, if I were to take this as, say, sum 2, okay, therefore, rewriting 2 or 2 becomes, it's going to be 100, okay, I'm going to take this as 2, okay, I'm going to take this equation as 2. So I'm going to use the value of K in this, the value of A in this. So I'm going to use all these values and I'm going to rewrite that. So 2 is now going to be rewritten as 100 is equal to 200 times e raised to the power. Now in place of K, I would be substituting the value of K, which is 1 over 2 times ln 4. Okay, this is what I'm going to substitute, times T. So I've got something like this. Now I can bring this 200 down and rewrite this as E raised to the power. Now, we got to be a little bit careful. So, how I'm going to write? I'm going to write this as e raised to the power 1 over 2 times ln 4, and that is raised to the power t. I'm going to write it like this. Now, why am I able to write it like this? Since a raised to the power mn can be rewritten as a raised to the power m, the whole raised to the power n. So, I can always do that. Now, from logarithm, right, I know that a times ln b can be rewritten as ln b raised to the power a. So, if I were to do that, then I can move this negative 1 over 2 to 4's head. Okay, so that's going to be 1 over 2 here, because these zeros would be cancelled, giving me e raised to the power. It's going to be ln 4 raised to the power 1 over 2 with a negative value before 1 over 2, and that is raised to the power t. So this is what I have got now. Now, of course, now t is equal to th. We know that, right? We can substitute that. So that's going to be th here. So that's going to be h there. Now the question is simplifying. So how are we going to simplify this? Now, if I use the concept that e raised to the power ln a, the e and the ln gets cancelled, giving me a. If I were to use that, then I would end up with 1 over 2 being equal to, the e and the ln gets cancelled, giving me 4 raised to the power 1 over 2, and that is raised to the power th. This is what I get. Okay. Now, in fact, I can actually rewrite this as 1 over 2 is equal to 1 divided by 4 raised to the power 1 over 2, and that is raised to the power th. I can rewrite it like this. Now, this is nothing but root of 4, right? Now, 4 raised to the power 1 over 2 is nothing but root of 4, which is nothing but 2. So, if I were to substitute that, this is going to be 1 over 2 is equal to 1 over 2, that is raised to the power of th. This is what I get. Now, I need to know the value of th. So, what I'm going to do, I'm going to take ln both sides. Okay, taking ln both sides, we get. So, what do we get? Maybe I can use the space here. So, this is going to be ln of 1 over 2 is equal to ln of 1 over 2 raised to the power th. I can bring the th down and write it as ln of 1 over 2. On the left is going to be ln of 1 over 2. Okay. Now, I need only th. So, from here, th is equal to, move the ln down. So, that's going to be ln of 1 over 2 divided by ln of 1 over 2. So, this is the final answer for the question. So, this is the time that it takes for the quantity to reduce from A is equal to 200 to A is equal to 100 milligrams. So, that completes the solution to this question.